Hello everybody, my name's Phil and this is Simon, we're from TradeMe. Today we're going to be talking about the Microsoft Azure product. We're not going to be diving too deeply down into the product itself. There are sessions later on in the tomorrow and Friday for those that want to get their hands really dirty. We're just going to talk a little bit about what we found when we had an initial play. Why are we interested in Azure ML? It might surprise you to learn that at TradeMe we don't do a lot of predictive analytics yet, especially real-time predictive analytics. We've been spending the last couple of years building up our BI platforms, our data warehouse, all our ETL, all our cubes, etc. And now we're starting to have a look much more seriously at predictive analytics. I think the timing's right because the tools now, not only from Microsoft, are getting pretty good now, certainly compared to what they were 5-10 years ago. And I just want to talk a little bit today about what we found. Simon works in our analytic team, and I look after the BI platform. So what is Azure ML? Essentially, it's a cloud-based platform for building production-ready machine intelligence, and it's the production-ready aspect that really quite excites us. It's highly collaborative. When you sign up for Azure ML, you're provided a workspace which you can share. And that helps when you're working in a team, when you're trying to quickly learn how to use the tool. We found it very useful. It's very drag and drop. If you haven't seen it already, there's most of the work you will actually do inside the Azure workspace is just dragging objects onto a desktop, onto a canvas. If you've used SSIS, it's similar, but with a sort of a more modern look and feel. No programming is required. You can do programming, but you can actually start producing useful models fairly quickly without writing any code, which actually tears me up a little bit, being from a coding background. I do quite like to write code, but some of the challenges that machine learning are required to solve are not easy challenges to actually solve when you're typing code. If someone came to me at TradeMe and said, look, Phil, we need you to write a function that adds two numbers together. You can imagine what that function might look like in C# or whatever. You declare the function, you have a couple of parameters in there. To accept the data coming in, you perform the addition function. You might do some tests to make sure that the result is going to fit into the return type, and of course you return that back. It's a very easy function to write. Whereas if someone came to me and said, look, Phil, we need a function inside TradeMe that will give me a prediction whether a listing is going to sell or not. Now, I might know what the function is probably going to need to know, like perhaps what the initial sell price is, a description about the actual product itself, whether there are photos, whether they've used some of the features inside TradeMe, like gallery and some of the other the goodness. But the actual code you would have to write to solve that would be really complicated, and it's not something I would want to actually pick up easily, and it's hard to actually imagine what that might look like. Whereas the Azure ML tool will solve that problem without writing any code at all, and that's pretty cool. You don't have to be a data scientist to actually play with Azure ML. It probably helps. I think it's important that you consider yourself a data professional. To me, a data scientist is probably someone with a mathematics PhD or a PhD in statistics, and they really know their stuff. But there aren't that many of them around. They're not cheap. Businesses usually have people that are probably more suited to the data professional label, analysts and developers and the like. The tool is fairly auto-tuning, and I'll show you in some demo videos how they actually can auto-tune. One of the headaches that you are faced with fairly quickly, or one of the things you might be worried about when you start your journey into machine learning, is what algorithm should I use? The Azure ML environment really helps guide you along the way, but also the documentation is pretty good at actually helping you pick a good algorithm. Azure Machine Learning environment provides you with obviously the capability to visually compose machine learning experiments. You'll see what they look like very soon if you haven't already seen yourself. You have access to 25 or more proven algorithms. These all come from Microsoft Research, Bing and Xbox. Some of the algorithms you might have seen in offerings like SSAS, but they might be earlier versions of the algorithm. The cloud provides you with the latest version of those algorithms, and they add them all the time. When I started looking at this product this time last year, there was a much smaller subset of algorithms and modules that I could choose from to bring into my experiments. Interestingly, there's first-class support for R. So if you're doing work in R at the moment, this is pretty cool and exciting. If you're not doing any work in R, I wouldn't worry about it. It doesn't matter. You can still produce high-quality experiments without the use of that. Although I think what you may find is that this might be a good excuse to start going down that journey of learning how to use R, which is a pretty cool tool. And from the sounds of it, it's going to be embedded in quite a lot of the Microsoft key products like SQL 2016. Collaboration, like I said, you can when you sign up for Azure ML, you're provided in the free version with one workspace. If you're using the paid version, you can have multiple workspaces. You can easily share that in a team. That's quite helpful. It's an all or nothing share. So if I want to share my workspace with Simon, he can see all of my experiments. So if you want to do things that you don't want your colleagues to see, you can probably just use your personal email for account for private things. I don't necessarily want to share my sports betting experiments with people I work with. And so who's going to win the Rugby World Cup? That's just only I know that. It provides tools, and this is actually the next point is where the Azure ML tool really does shine. It provides the tools to immediately deploy predictive models into a production and web-based environment. Machine learning is not new. It's been around for a long time. It's probably more been known as data mining. Data mining as a term has a bad name now, so everyone just calls it machine learning. It'll probably be in about 5 years and we'll have to call it something else. But yeah, earlier tools, you could produce experiments, but they just wouldn't scale, and it was very, very hard to actually get them into a production environment. So you could take a cut of data, you could throw it into a data mining tool set, play with it, learn some things, look at some decision trees, but to actually rip that out and embed it into your application, be it a web application or whatever, was a really hard and expensive thing to do. Probably in the order of magnitude of tens to hundreds of thousands of dollars for a typical project, whereas here you can be up and running for free very quickly, or even the paid version. It's not going to cost mega dollars to actually to have a production API that your applications can call. And most importantly, I think the tool does give you the ability to produce accurate, reliable, and useful results. So my take on the product is that it's accessible machine learning for anybody, anywhere. All you need is an HTML5 compatible browser. So you can actually be doing machine learning on your tablets, devices, phones. It's a bit easier on a PC. But you don't have to install any executables or any clients on your machine. You can mix and match between home, between PCs. Everything's nicely kept in the cloud. If you have some long-running experiments that might take a few hours, you can kick them off, shut your PC down, go away, come back, pick it up on another machine, and you can see exactly where it's up to, and that's kind of cool. Obviously, you need an internet connection. I've read stories, I'm actually quite jealous of this, people who fly around the States domestically now have pretty good internet service, so I read stories quite jealously about people in their seat, machine learning, connecting to the cloud, while they're actually flying between Chicago and Seattle or wherever. And the visual aspect pretty much means you just drag, drop, connect, and configure. Okay, so there's a picture of it all.
Cheers. So I guess we've all been to VEDA presentations where someone stands up and shows you this cool tool that they want you to buy, and they use some data that they've prepared and cleaned themselves, and they're solving a problem that is specifically designed to work exactly with this tool, and lo and behold, everything works great. But what we wanted to do was use this tool and understand what it could do with real TradeMe data and a real TradeMe problem. So what we decided to do was host an internal competition in our analytics team to really get everyone struggling with this product and using real stuff and trying to solve a real problem. And the problem we chose was predicting the outcomes of auctions.
And we offered some pretty sweet prizes too.
We offered some very sweet prizes. So we predicting the outcome of auctions, so whether they're going to sell or not sell. And that's sort of the bread and butter of what TradeMe does. And understanding that better is a really helpful thing for our business. If we can understand the value of our premium products, if we can understand the best way to present a listing, if we can help our sellers to make the listings as good as they can, then that makes the site better for everyone. So it's a key problem for TradeMe, and so it's something we wanted to really understand better. And this competition that we set up, we thought would be a great way to do that.
Cool. So what we did was I went around all the analysts and got them started in Azure ML. So we just, at their PC, we fired up studio.azureml.net and created a free account. All of the work we've done so far in TradeMe so far is just using the free version of Azure ML. We haven't delved into the paid version. If you are already using Azure, you can just spin up, using the Azure portal, some Azure ML type workspaces. You might have multiple workspaces. So you don't need a credit card. You don't even need an Azure account. You can just simply go in with your private email address. Pricing, I've got a slide a bit later that gives you the difference between the free version and the standard version. Basically, the free version is just smaller and slower. The paid version is not too expensive either. One of the things when you do go into Azure ML is it provides you with a gallery, which is essentially a collection of ready-made examples and solutions and problems that you can just go and grab, and they include data as well. There's probably the most common one you're likely to encounter first is the Titanic, where the data that is provided is the passenger list, and it gives you passenger names, age, gender, where they stayed, what their occupation, all those sorts of things. And one of the columns that is provided is whether they survived or not. So you can copy the model and even enter your own data and see whether you were likely to have survived the Titanic disaster. There's about 300 examples from Microsoft. They're really nice and clean, quite useful ones to sort of go in and borrow best practice from. But there are plenty that people have loaded from members of the public as well, and the quality will vary on those. If you are interested in who's going to win the AFL, the chances are there's 3 or 4 experiments that you can go in and grab and look at techniques that other people have used. Oh, and here's a slide. I don't think this is probably very readable. That just gives the difference between the free version and the full version. The key part to me at the bottom is that the standard pricing for the paid version, the monthly fee is $12.23 per seat per month. I don't know if that's US dollars or Australian or New Zealand dollars. And then hourly is just $1.22, and you pay for, when you publish your web API, how many predictions are going through that. So you probably do have to be careful about who you let know what your API endpoints are. So we got this competition underway. I thought I would start the ball rolling by just doing the most basic hello world equivalent of a machine learning experiment, and I'm going to walk through a video of that. What it essentially does is start with some data. I can't remember what the category was. It might have been women's shoes or something. I grabbed a few months worth of historical data, loaded it into a CSV file, brought it up into the Azure ML world. Then what I wanted to do was split the data so that I could validate the experiment at the end. This is a common technique in machine learning where you will use perhaps 70% of that data to train your model, and you set aside 30%, which you'll use later to just test the quality of the model. You need to select an algorithm, and then at the end of the experiment, you will simply score the experiment, which is machine learning speak for making a prediction, and then evaluate its performance. So before we start this video, so this is the Azure ML Studio when you first look in. On the left-hand side, the menu controls some of the bigger things you need to manage inside the environment. First of all, you'll see your experiments that you can open, load, edit. You have your any API web services that you've published. There are some Python notebooks. This is quite a new feature that's only been added in the last couple of weeks, which will be exciting if any of you work with Python. Simon will probably chat about a little bit more about that later. Data sets. Now this is where you can upload data to the Azure email world. There's a school of thought that maybe says you shouldn't upload data via CSV into a Azure email world, that you should use the alternative method. And there are a bunch of data sources that Azure email will recognise. Most of them are Azure data sources like Azure SQL Data Warehouse, Azure SQL Server, Azure Virtual Machine, the Azure Hadoop. And the main reason why you might select that over uploading a CSV is just simply for data formatting, so that the experiment quite clearly understands when text is text and when numbers are numbers. Whereas if you throw your data up into the Azure ML environment in a CSV file, you may have to go in and just specify, okay, this is definitely a number, treat it as a number. But for getting underway very quickly and easily, throwing up a CSV file is pretty good to just work out how it's going to go. Trained models will be models that you've trained, and settings will be where you actually share your workspaces and manage who can see and who can't see your workspace. So if we get that underway,
No.
I can go back. Is there a play?
Yeah, sort of. Kinda.
Cool, looks like we're underway. So we're just going to go blank experiment. You can see here the gallery. There's some of the other experiments that you can do. If you could pause that, Simon. So this is the actual machine learning designer. On the left-hand side, I've got my left and right, so I'm a bit dyslexic with left and right hand. These are the modules and resources that you will use to drag and drop onto the canvas. It's drag and drop. You pretty much start at the top, and then your waterfall flow the data down through the experiment. On the right-hand side, there's a properties area. So any module that you have focus on, the relevant property dialog boxes and text boxes and settings are always on over here, and you can squeeze that away to give you some more space. And yes, obviously there's the canvas in the middle. So what I've done here is I've dragged some TradeMe data across. There's 6,500 records of fridge freezers. And if you could just play that again. And if you right-click on the node on the object, you can visualize what that actually looks like. And when this comes up, you will see a whole bunch of columns with the sorts of data that you might expect to see if you're doing an experiment on predicting whether a TradeMe listing might sell or not. And there's some really good descriptive statistics that you can find in there. The next thing I'm going to do is split that data. So I'm starting with 6,500 records. What I want to do is use the bulk of that to do my training on, but I'll leave aside some to perform the test. This is like validating the experiment. And in the properties panel, you can see I've said I want to set that a randomized split, 70%, which is about 4,500 records, which I'm now moving into my trained model. I need to pick an algorithm. I'm not going to go into the detail about which algorithm's best at this point. I'm just going to pick the simplest, which is two-class logistic regression. Two-class is a binary thing. All I want to do is predict yes, no. And I want to predict whether the column is sold as one or not. Now, this is a supervised experiment, so this is all history that we know the answer to, and it's going to learn on. Finally, we want to score the model. Again, score is a data mining term for just make a prediction, and we want to evaluate the model. So at this point, the left node on the split sends data to the train model, that's where it ends, whereas the right node, that's where it's going to send about 2,000 records down into the score model object. That's going to make the prediction and then test to see how well it actually performed. I've run the experiment. It was very, very quick, lots of green ticks. That's a good thing. And what I want to do is have a look to see how well that went. So I don't know if you can pause that. Let it say, right. Now, this experiment has performed very well. In fact, it's managed to accurately predict every single one of those 2,000 odd records. Now, that sounds good, but probably too good. What I'm looking for is more a curve. The reason why this has done this is because in my data set, I've got a couple of additional columns that the the algorithm has quite cleverly picked up as strong indicators of whether these listings have sold or not. Those two columns are the quantity sold and the quantity price. So when there's a price, it probably sold. When there's a quantity greater than 0, it probably sold. But it demonstrates that it managed to pick that up. So what I'm going to do now, if you carry it on, is just correct that problem in the environment. And you'll see the effort involved in actually making that correction. Still not a single line of code has been written, certainly in Azure ML. Some code has been written prior to get the data, but you can do a lot of that sort of data manipulation and fixing actually in the environment. So this module, Project Columns, allows me to pick and choose what columns I want to let flow past that point. So I'm now going to tell it to exclude these two particular columns that it was cheating on, and they're essentially going to be ignored. So sold price and quantity sold. So I can rerun the experiment. I don't need to do anything more. It should run nice and quickly. And I can recheck that evaluation. So it's now, the score model module actually appends two columns onto the data set. The first of all is the prediction column, 1 or 0 for yes it sold or no it didn't sell, but it also puts on a probability, which we might see in a minute. So the evaluation is now going to look much more realistic. Oh, so this is the score model data set. So you can see at the end there are two columns that it has appended on. So where you see a 0, it's predicted that won't sell. And the probability, anything that's 0.5 or higher is the clincher that it sold. Anything that's 0.5 or lower means it didn't sell. So when this slows down, perhaps going back to the top, you will see that the top entry, it predicted that it wouldn't sell, but it was so close. If perhaps one thing in that line was slightly different, it maybe would have made the difference between a sale or not. And the evaluation is a much more realistic lift curve. This is reflecting how many it got right. We're going to talk about a little bit more in more detail about that later. Another cool feature is that there is a run history. So this was a brand new experiment, and every time I've run this experiment, you can actually go back and look at the results of that run. So if you do find you're making a bunch of changes and you've gone off on a bit of a tangent that you want to get back to, every single time you run an experiment, the results are stored, including all of the data and whether it passed or succeeded or not, so that you can jump back up the tree and perhaps diverge and start working off on a different tangent. So that's when we created the competition. This was essentially my first effort. I didn't put a lot of thought into the algorithm I was going to use. I didn't put any thought into the modules I was going to use. All I wanted to do was just get a score on the board, email the results to everyone and go, right, beat that. Oh, and here's in the help, quite a helpful cheat sheet that if you're trying to decide which algorithm to use, you can sort of follow this down. In my case, I'm trying to predict categories. I'm not trying to predict 3 or more. I'm just trying to predict 2 categories. So binary classification problem. And it suggests there might be 9 that I can choose from. And there are some guides to say, well, if you've got a lot of features or a lot of rows or not many, perhaps this one might be stronger than that one or whichever. But I'm going to show you some other techniques to help you tune and pick perhaps which algorithm is going to be best suited to your data.
So I guess I'm quite competitive. So when Phil posted out his score and his model that he got, I stayed at work pretty late trying to beat him. And the first thing I noticed when I looked at what he'd done, because I could just go into his workspace and look at exactly the model that he'd built and looked at his data set, and the first thing I noticed was that the data that he was using didn't make sense to me intuitively as the most relevant stuff for whether a listing would sell. I think he'd chosen sort of 12 things almost at random, and I thought, I can do better than that, just using my business knowledge. And it turned out using some of the tools that Azure ML provides. And the first one of those that I looked at was this filter-based feature selection. So what that does is it tells you the statistical correlation between each of your columns and the column you're trying to predict. So if you're trying to predict if it's sold or not, like I was, it tells you how correlated is each of these is this thing with whether or not it sells, which is a really useful thing to know when you're building a model on this data. And so what that showed was some quite intuitive, some stuff I expected and some stuff I didn't expect. And so what we can see is over on the left, this is the output of the module. It gives you this, it tells you the ranks and scores of all of your data. I found that dollar reserve turned out to be pretty important. If you're selling something for $1, it is pretty likely to sell. Number of photos was a big predictor, as you can expect. Mostly what that's about is that if you don't have any photos, people don't want to buy something they can't see.
Now this result set's just for one specific category. It's not for all listings on TradeMe, regardless of what category you are. So if you're using a slightly different category, and we did choose very different ones, the order and the weightings of this kind of view would be very different.
I was all about women's shoes. I think I'm probably New Zealand's
Why were you
foremost
about women's
expert.
shoes? Is there something I don't know?
Yeah, I think, well, now I can say that I'm probably New Zealand's foremost expert on selling women's shoes on TradeMe.
That's good to put on your CV, Simon.
Yeah. So in trade was a really interesting one. Professional sellers are a little bit less likely to have their listings sell than you or I would be, and that's because they've got a much bigger inventory and their prices are a lot sharper. You know, they're a lot closer to market value, so they tend to list in higher volume, but consequently have a smaller sell-through rate. Some of our premium products are in there next, which is good to see that if you spend extra on some of our premium products, you are more likely to sell. And then the time of day and the day of the week that your auction sells on is also really related to whether it's going to sell or not. Which is, if your auction closes on a Sunday when everyone is looking on TradeMe, then you're more likely to sell, which is makes sense when you think about it. The other thing I looked at was trying to create some derived variables. So that's combining a couple of different data points together to create a combined data set that might be more predictive than either of them alone. And Azure ML's got a lot of tools that let you do that in all sorts of fancy ways, but being pretty familiar with SQL, like I imagine most of you are, I found that I could do 90% of what I wanted to do with SQL and create some quite sophisticated transformations just with the SQL transformation module. The only caveat being that it's SQLite and not T-SQL, which is a bit like speaking Dutch when you're a German speaker or something. I don't know, I find it drives me crazy, but it worked all right. So, what happened? I beat Phil is the main thing. I was able to get a slightly better score than him. So, I'll just explain a little bit what I'm showing you here, which is an area under the curve. It's, I guess the thing is that just predicting, just accuracy alone isn't always the best thing. If you imagine a category where 95% of the listings are started sell, then I can create a model that's 95% accurate just by telling you that everything's going to sell, right? So the point is, it's not just about getting it, how often you get it right, it's how much better you do than a chance outcome. So what this area under the curve is showing you can't see it very well, but if you imagine that 45-degree line, from top left to bottom right to, you get me, is that's a chance outcome, and then that blue curve is what we got with the model. So the difference between the straight line and the curve is how much better the model did than chance. And so you can see that Phil got about 0.587, so that's marginally better than chance, and then I got 0.69, which is a bit better than chance. Later on, we ended up doing models that did even better than this. So, and Phil's going to show you how he did that.
Yeah, so I had my Hello World experiment, which was very, very basic. Simon looked at some techniques and ideas about how he could make that better. So I thought, right, what are some different ways that I can go so I'm not simply just copying Simon doing what he's doing. And a couple of my favourite features about Azure ML are the two that I'm about to show you, multiple models and sweep parameters. If you're lazy, they can quickly tune your algorithm quite effectively. Multiple models allows you to drag not just one type of algorithm onto your canvas, but you can have as many as you like. I'm going to show you a demonstration that just shows 2 models, but most of the early work I did would have 4, 5, 6 models. The only cost to you there was just it would take longer to run. And that would allow me to select the algorithm that best suited my data without having to think about it too much, without having to go and ask a data scientist, look, here's my data, can you study it and then give me what you think is the most suitable model? I can just pretty much just shotgun effect, put them all on, let it run and go, oh yep, that one's producing the best results, let's focus in on that one. The next technique is sweep parameters. What this allows you to do is tune the algorithms. When you drag one onto the desktop, onto the canvas, you're effectively getting the default parameters. The default parameters will probably be good and probably give you acceptable results. But I don't know if you remember in the designer, on the right-hand side, there were some text boxes and drop-downs that you can go and change a 2 to a 20 or a 1 to a 0.1 or whichever. Now, I wouldn't have a clue what I'm doing in that sort of experiment, and I don't know whether I would be making it worse or not, and if I'm changing more than one at the same time, whether I'm just going around in circles. So what sweep parameters will allow you to do is effectively iterate over a bunch of different parameter selections. The default approach is what it will do is it'll take 5 randomly spaced sets of parameters, but you can actually ask it to do 10, 20, 100, or effectively sweep the entire grid. And I'm about to show you a video of what that might look like. So our starting point, if you could hit play for me please, is the end of the experiment we just built just before, so my first experiment. So what I'm going to do is extend this by now bringing in a new algorithm. So I jump over on the right-hand side, left-hand side to my modules. I drill down into machine learning, train model. Okay, you need to get a train model. I'm now going to go and actually find an algorithm, which I'm going to associate with that train model. So, and you can see when I expand this how many other algorithms there are to choose from. There's a really good help in the bottom right-hand corner as well. If you click on that, that takes you to a great screen with lots of information. You'll see on the right-hand side the parameters that I'm talking about, which we'll get back to. Now here's the key. The split data is now sending from the left-hand side exactly the same 70% of randomized selection to both algorithms. So you've got a fair apples with apples, oranges with oranges comparison for later on. And now I just need to finish off what will be symmetrically the equivalent. I'm just going to match up the test data, bring it into evaluate. So in the same evaluation model, I can see them side by side. And I'm going to kick that off. And everything's running with default values. I'm not changing anything at all here. That's going to sort of fairly quickly run through. Now, I could have 4 or 5 or 6 or 7. You could get OCD with the way you line these things up to make sure it's nice and symmetrical. You create some art. And here we're going to visualize how the 2 models compared. So we've got the lift curve of the left and the right hand side by side. Interestingly, the AUC is 81 and 83%. The accuracy, I can certainly compare between the 2 models which one's probably doing a better job with my data. So now what I'm going to do is use the sweep parameters object. So I get rid of the train module, and these are the parameters that I can manually set if I know what I'm doing, and I don't pretend to know what I'm doing. I don't think I actually want to know what I'm doing necessarily. I can probably do better things. So here we bring in the sweep parameters. Now the default set will be 5 runs. So both of these sweep parameters will just iterate over 5 randomly spaced sets of parameters for my algorithm. And you can see I pretty much plumbed the flow of the experiment exactly the same as what I was using before with the trained model. So once we have that all nicely plumbed up, we can kick off the experiment. Now this will take longer than the experiment that we just ran because essentially it's running 5 times for every experiment. So I do speed this up. Otherwise it probably you would be sitting here for 3 or 4 minutes waiting for this to complete. I don't know whether the paid version would be a lot faster. So this is going to run. And what we can actually see, the left-hand side must be quite a light one. Oh, you can see that the kind of things you can optimize your sweep parameters for, sorry. So this is now running. The left-hand side completes fairly quickly. It does take advantage of caching, which is pretty neat, especially when your models start to get more sophisticated. So I should be able to actually focus on the score model on the left and see the parameters that it decided were most optimal out of the 5 that it selected. That's the part that sort of will actually sit there for about 5 minutes, but I did speed this up. So when we visualize that particular node, it's going to present to me, among a bunch of other information, the values that it found that performed the best. And if I close this screen, I can actually see what it had to choose from and how that ranked. Now, interestingly, the right-hand side is still going, the experiment's still running, I can explore. Now, I've got 5 lines here because it iterated 5 times. If I'd asked it to do it 10 times, I'd see 10 lines. The first 4 columns are the parameters, the rest are the performance results, and it's sorted by accuracy because I chose the default sorting of accuracy. So what I can now then do is remove my score model. I can bring back in the train model and I can manually set the train model to those values, and it will run much faster the next time I want to do this. So how did this go? It's not much better, but what we can see, the AUC that was 81 and 83 has jumped up to 82 and 84. The other numbers are all just slightly better. What I could possibly do with sweep parameters is ask it to perhaps run 20, 30, sweep on the entire grid. We did do that a few times. I think the models were taking 12, 24 hours to run, but the great thing was we could turn the machines off, go away, come back the next day, and they were just still chugging away. Once they complete, we could get lots of descriptive statistics from all the various nodes through the experiment, and as data professionals, we could then get the model back to something that ran pretty well and could produce some pretty good results. On the data sets we were playing with, we were managing to get the accuracy up to the high 90s for some categories, and that was quite interesting, although there are some drawbacks with that. So that was my 3rd attempt. I'm looking at running, or my 2nd attempt, I'm looking at running modules in parallel, and I was getting some pretty good results. So I'll let Simon know what I did.
Yeah, so I'd kind of got as much juice as I could out of choosing the right data to put into the model, and then Phil had got everything there was to do out of choosing exactly the right algorithm to use for that data and exactly the right parameters. And so it seemed like there was nothing else we could do except get a little bit crazy. So I went and stole Phil's work from his workbook, copied it into mine, and then tried to see what I could do using some of the more advanced features in Azure ML. So I had a look at scripting first. That's dropping in some R code or some Python. I didn't get very deep into that because I didn't have a lot of time, and I know next to nothing about R and very little about Python as well. So it was I was probably not going to get a lot of juice out of that. But there is a talk tomorrow morning which looks very interesting about using R. I'm sure you'll learn a lot more from that. But one cool thing that I noticed is that I'm starting to do a lot of stuff in Python now, and it's got native support for Python notebooks, so you can open up a Python notebook in your browser, write a bunch of code in there, and I think it asks you to use some particular naming for your data sets and some particular method names, and then you can drop that script into your experiment just as a module and apply transformations and do whatever you want to your data using that. But what I was really interested in was the feature hashing, which is one of Azure ML's text analysis tools. TradeMe's kind of got an interesting problem as an auction website where we don't actually know a lot of information about what the things we're selling really are. We've got the category, but that can hide a whole lot of, we don't have like a unique product ID for everything that we're selling. So when someone's selling an iPhone, we don't know if it's an iPhone that works or a broken iPhone, and those are very different things that we've got no idea about it, except for the text. And text is something that for a human is really easy to understand, but for the algorithms, it's very difficult for them to pick up any useful information out of just what looks to the algorithm like a bunch of letters. So what feature hashing does is it takes the text of the title or body of the listing and it turns that into data that the algorithm can use. And it does that by identifying all the different words that are used in all the listings and then creating as many columns as you want. So it turns your one column of text data into 10 or 20 or 2,000 by mistake one time columns of data that it can look at. And each column represents one word and whether that word or combination of words is present in your data. And so you end up with a data set that looks like this. It tends to be very wide and very sparse data. So each of these hashing feature 1, 2, 3, and so on represents one word, and then the number represents the count of how many times that word shows up in the column that I'm analysing.
Yeah, so the data set that you upload into the Azure ML might start with 40 columns. You turn on feature hashtag, all of a sudden you've got 1,040 columns, which is kind of useful because the algorithm can then assess all of these additional ones and potentially find a small number that are highly relevant to the problem it's actually going to solve. And that's quite important.
So then another problem that I had, I was looking at women's shoes still, and what I found is that the brand was quite important for working out whether it was going to sell or not, that some brands are more popular than others. But not everyone populates the brand in their listing. Some people can't be bothered identifying what brand their shoe is, but that the name is present in the title or the body of the listing. So I thought there must be a way of working out what brand a shoe is based on the text. And it turns out that there kind of is. I mean, there's lots of ways of doing it, but I found kind of a cheeky way of doing it, which is this named entity recognition. So somewhere in the background of Azure ML, they've got this huge database of names, of places and of people and of organizations. And this named entity recognition module will look for the presence of one of those names in your text and then return a data set that shows you all the names that it found in your text. And it returns a data set that looks like this.
And this is just as simple as dropping the module onto the canvas and plumbing it in.
So these are my women's shoes, and you can see it's found glittery black high heels, which it thinks might be an organization. It's found Kardashian is obviously a person. And then right down, it's found Custom Black, who's a person. I like to think that he's a 70s detective. So with a bit of fiddling, I was able to plumb that data back into my data set and create a brand column that contained some of this, that patched up some of that missing data. And then I got into ensemble techniques. So ensembles is it's a fairly traditional part of machine learning, which is using the output of more than one model to make your prediction. So you kind of come up with something that's greater than the sum of its parts. And so what I did is I started with a sort of basic hello world that Phil invented, and then I tried a few different things. I tried splitting the data left and right. So I tried making one model for one kind of listing and another model for the other, and then combining them again at the bottom. And then I tried a more traditional ensemble, taking 3 trained models and then using the scores of those as the inputs into a fourth model that would make a prediction that was better than either of those. And then I got a little bit crazy. But importantly...
Did that one actually work?
Yes, I beat Phil.
All right.
It was marginal, but I got there.
That's the main thing. All right. So I think one of the areas that Azure ML really does shine is this ability to get these models into production. We've had this ability to data mine some models up in other tools, and but what we could actually, in fact, do with these models we were playing with in our competition was publish them and use them and potentially even plumb them into the TradeMe application with a bit more testing. So I'm just going to show you how easy that is to do. Once you've got your experiment run and you're happy that you've chosen the algorithm that suits your data set the best, in the bottom toolbar there's just a button that's simply set up web service. When you click that, it takes you to another screen that has a slightly modified version of your experiment. There's a nice animation that transforms, basically sucking out things that it doesn't need, making it bare minimum. And when you're at this point, all you need to do is click this button, which is you probably can't see, but it says Deploy Web Service, and it's as easy as that, 2 clicks. When you hit Deploy Web Service, it will create a public API endpoint that's accessible from anywhere. It'll drop you onto the screen that you can come back to in your web service area of the ML Studio. On the screen, there's a button that'll pop up a dialog for you to just key in some values if you want to just do some simple tests like, this had 5 photos and we used gallery and this was the title and I just want to go, okay, give me a prediction, and the prediction will come back on the screen with saying, no, this won't sell, and there's a 0.2 chance of it selling, or yes, this will sell, for a 66% chance it will sell. You can download an Excel workbook, which I think is quite neat. What they do is they spin this up on the fly, they pop some VBA code into the back of the Excel workbook, which is pre-populated already with your API key and all the important things it needs to know where to call the API. When you open the workbook, it dynamically builds a nice table that you can just start keying in data. You can cut and paste rows of data, and as you're doing that, the Excel workbook will take each line, throw it out to the API endpoint using request response service, and then when the prediction comes back, it displays it on the screen. This is quite neat at TradeMe because it means that we can really start to get a feel for which columns, which features do make a difference for that particular category. I can start playing with the number of photos and changing it from 0, 1, 10, 100 and seeing what effect that actually does have on the is sold, or whether the description just needs more text, or whether I use gallery or not. There's also an area that you can go into which will, when I click either of these links, it will provide C#, Python and R code that you can just straight away cut and paste into Visual Studio or the Visual Studio equivalent. There are everything's done in JSON, which is sort of seems to be used more and more these days. It's essentially a fat-free XML. You can paste your JSON into your Visual Studio, and it will actually, if you paste it in the right way, it'll create all the classes. So the amount of coding that you have to do even outside Azure ML is you're helped along with. So what I have here, what we did for our experiment was we created some space in our data warehouse. We created some tables that we were going to store our test and train data. We sent some data up to Azure ML to do the learning on, but then once that was all done, what we wanted to do was fresh new data that was coming in each day. We wanted to run through the API predictive experiment. So we just used SSIS component. This is code that's just ripped straight from the Excel spreadsheet. And what would happen every day is these 2 columns here, the scored labels and scored probabilities, were coming back, and we could then compare that with what actually did happen. So that we could see whether Azure ML was cheating. It's just good to know for real how the prediction API was performing. We didn't spend an awful lot of time on this, but importantly, you can programmatically retrain your model. So if you did hypothetically generate a model this time last year, you're not necessarily going to want to continue to use the exact same model. If I took data from January, February of TradeMe sales, that wouldn't really be that necessarily relevant to how well things will sell next week. And in our case, the site has changed a lot. So it's important to keep the model fresh, and there are some programmatic techniques that allow you to do that. We're not going to go into that today. So what we found, some results. Now this is only a subset of the some results we found, and what we have here, the first 5 lines actually all belong to the same model, and the reason why I've included them is because inside the model we managed to screw the accuracy or the AUC up as high as 97%, which sounds really, really good, almost too good to be true. And what we found was it was too good to be true. When we started throwing data, fresh data at it, certain kinds of smartphones, so A1 and A2 are the same generation of a particular smartphone, they didn't do too bad. 88%, 86%, that's going pretty well. But when you take another generation of the same smartphone and put it through the same algorithm, it doesn't necessarily perform so well, and there's even actually another variation which was pretty poor. Depends how you look at it, I guess. Home appliances, inside Azure ML, we managed to screw it up to 92%. What we found on real data was it was running at about 78%. Simon's effort, Snigger, was performing 80%, on real life data was 58%. So what that probably suggested to us was there's a heavy degree of overfitting going on. So perhaps we were pushing things like sweep parameters too far, and we were making the algorithm suit the data set much, much, much too closely. I think perhaps what we would be better off is having an algorithm inside Azure ML that was reporting a lower value, but then in real life, we would be seeing the same value. So if we were to progress this into production, I think our testing would want to see this number much, much closer to this number. And it doesn't necessarily mean this number has to be higher. What we also did was we set one of our analysts a challenge to see if they could predict the outcome. So we gave them an Excel spreadsheet with 100-odd lines, exactly the same data that we sent up to Azure ML. We got them to sit and go manually, oh yeah, this will sell, this won't sell, this won't sell. They read the title, the description, they had all the same data. And the human made 105 predictions, 69 of them were correct. This is against Azure ML's 97%, it was a smartphone data. And the human got 65%, which is probably the figure that I was expecting. That's not too bad. I didn't do it. It sounded like a really boring task. I'm pleased I managed to talk someone else into it. What I also did in the same spreadsheet I gave to them was I just put a random guess column in. So I just put random 0 or 1. And of the same 105 predictions, it got 54 correct. So that's probably about fair, just not too bad for a random guesser. So, so that's what we found. What else did we learn? We learned that the product's very easy to use. It certainly lit a fire. Some of our analysts had never done any machine learning, and those analysts some of them were up till 2:30 in the morning in our competition. They really enjoyed using the product. It's time, I'm conscious of time. So I think the key message, going back to the start of the presentation, is that the Azure ML toolset definitely provides much more accessible machine learning to anyone, anywhere. And as you know, you only need a browser, an internet connection, drag and drop and configure, and you're away, and there's our dog again. Other applications that you might use in your own world for Azure ML, this slide's a Microsoft default slide, so all the sort of things you probably might expect to potentially use this for. Actually, Netflix recommendations. Netflix is an interesting case. I don't know if they use Azure ML or not, they probably don't, but not only do they use machine learning for their recommendation engine, so I watched this, so we think you might be interested in that. I understand now they're using machine learning to develop plots for their own series that they're filming, and so that's kind of scary. It's sort of taking the whole artistic creativity out of it, but when you think about it, it's quite a sensible thing to do. You spend a lot of money in producing content, and you want to make sure that you're not going to be halfway through a series, put something dumb into the plot, everyone switches off. Which takes me finally into an interesting stat. You can learn anything off the internet these days. This is something I picked up the other day, that human-level artificial intelligence by 2030 or sooner, if the bar keeps dropping. And lastly, there's only 107 days till Star Wars. Is that cool or what? I'm looking forward to it. So selfish, Trade Me are always on the lookout for awesome staff. If you consider yourself one of the best in New Zealand at any one of these, please contact us. Go to our website, go to careers. We've got some great opportunities. It's a fantastic company to work for. We've got offices in Auckland, Wellington, Christchurch. I can't rave about the company enough as a company to work for. We're always highly placed in the best workplaces surveys at the end of the year. And we have some more, hopefully, or certainly I'm expecting more deep dive information on Azure ML if you want to learn more about it later on in the week. Unfortunately, the bottom two happen to be at the same time, because Peter Myers always produces some pretty good presentations, and I'm sure these guys from Microsoft will do a pretty good job, and I'm looking forward to this one tomorrow too, especially the more information about R. So the usual resources slide, and of course, please fill in your evaluation. That'll be really helpful, but not only to me, but to Microsoft. Thank you.